So last video we talked about two lines that intersect, a system of equations. Now we're going to look at a system that involves a linear, which is a line, and a quadratic, which is going to be a parabola that either opens down or up. So let's consider a couple of these equations right here. Let's do the first one. Consider the function y equals x squared. Well, y equals x squared, this is going to be a base graph, like when we learned how to transform the graphs. So the base graph is always going to have, this little shape like this, a u facing up, x squared. It's the base graph. You're going to have to kind of have that one memorized because we're going to use it commonly or often. And then the next one is y equals 2x minus 5. So, notice we're not using your graphing calculator. We're going to just do this from knowing how to do graphing. This is in the form of y equals mx plus b. A reminder, you're going to graph the y-intercept first. Okay, graph it first. So we're going to go down to -5, -4, -5. And then our slope is the number next to the x. So we're going to go from this point up 2 over 1. Slope, remember, is rise over run. This is all positive, so up 2 over 1, up 2 over 1, up 2 over 1. Okay, and you're going to see that this graph looks like this. How many times do these graphs intersect? None. So this is an example of no solution. Estimate the points of intersection. When there are no points of intersection, you put no solution. Okay, very simple, just practice graphing. Let's look at the next example here. Consider these two graphs right here, and we're going to graph them. Let's do the second one first because it's already in the form of y equals mx plus b. So you see my b is -3, b equals -3, and my m equals -5 over 2. So I'm going to go down to, can you see this? Go down to -3, 1, 2, 3, and my slope is down 5 over 2. So I'm going to go 1, 2, 3, 4, 5 over positive direction 2. So I know my graph's going to look like that. I can go positive 1, 2, 3, 4, 5 as long as I go -2. And then my graph's going to look something like that. Okay, a nice straight line. Pretend it's straight. And now for this next one right here, f of x equals x squared minus 2x minus 8. In order for us to graph this, we need to put it in the graphing form or the vertex form. So what I'm going to do is I'm going to say x squared minus 2x, kind of move this 8 over to the other side, so equals 8. Now what is it that we have to add here? Half of 2 is 1, 1 squared is 1, so I'm going to add 1 to both sides. So I get x minus 1, quantity squared, equals 9. Okay, that's going to help us find our x-intercepts, but first of all, let's find the vertex. The vertex, I have to set this equal to 0. So I'm going to get x minus 1 squared minus 9 equals 0. And this is the graphing form. Graphing form or vertex form. Right, so from that I can pull what is my my vertex. Well, I take the opposite of the x, which is 1, and then whatever that number out I use for the y. 1, -9. So I'm going to go to 1, down here to -9, and there is my vertex right here. Now I want to find my x-intercepts. Well, I can use this form right here and solving it by taking the square root of both sides. You get x minus 1 equals plus or minus 3. So we get x minus 1 equals 3, x minus 1 equals -3. And we're going to solve that. We're going to add 1 to both sides. And we get x equals 4. There's one of my x-intercepts. Add 1, x equals -2. There's my other one. Why is that so helpful? Because I'm going to come over here to 4, 1, 2, 3, 4, and come over here to -2. And there is that graph right there. Okay. So that graph is going to look something like that, right? So how many times does the graph intersect? It looks like it intersects up here and down here. So 2 times. And estimate the points. Well, we don't know exactly what they are, but we're going to estimate. Maybe it's this point right here. So I'm going to get, what is that? 1, 2, -8. So 2, -8. We're just estimating right now. We haven't done the work to figure out exactly what they are. And then this one might be this point up here. Let's just say that it's 1, -2, +2, -2, 2. So this is just an estimate, okay? Estimate, okay? My guesses may not be entirely accurate, okay? But since I just took the points from the graph. But it's close enough that I can definitely see I have 2 points of intersection where the 2 lines cross. And then it looks like it's those points. So we'll talk later about how to find exactly what those points are. But for now, we're just learning how to graph and determining how many intersects there are and estimating what they are. So for homework, I really want you to just play around. This first part is fun. As you have seen, sometimes graphs of 2 equations never intersect. However, when they do intersect, how many different intersection points can they have? How many intersection points can 2 lines have? How many intersection points can parabolas have? What about a parabola and a line? In this problem, you will investigate these questions. So I'm not going to give you the answers to these 2 right here. You're going to draw a line and a parabola that intersect 2 times. Well, that's easy. We just did that on the previous problem. Here you're going to draw a line and a parabola that only intersect once. Like, try to play around with it, and how does that work out? So this should be a fun thing to turn in. And then when you get down here, you're just going to graph these 2 equations. So x squared is your base graph that you should know. This is already in the form of y = mx + b. This is -x squared, so you know it should point down. And then, so this one problem right here, you're going to have to put it in vertex form to find it. And try to do it without using the Desmos graphing calculator. Try to do it on your own. If you really get stuck, go ahead and use the calculator. I can't stop you from that, but I want you can use it to check your work. All right, we're going to turn in page 4 to Schoology. Have a great day.